questionable content or content that might be appropriate for certain regions, the Vision API can highlight that for you and stop you before you've, and identify it for you and help you kind of not put it in that compromising position. One particularly interesting use case that we've seen of the Vision API, and this is a very, very nascent one, is recognizing legal contracts from PDFs. So for example, you may have a video that you might not have the rights to distribute in various regions. Extracting that information from those contracts on a PDF can often be challenging. But with the Vision API, it's possible to eliminate a lot of the manual effort that would go into that. And the Vision API accuracy is actually very, very high. So machines can now see like humans. This is some old data, as you can see, from 2015, so we're constantly getting better at it. But in terms of identifying images at scale, the Vision API may actually be even better than what, or comparable to what a human can do. So in terms of recognizing pictures, the Vision API is actually quite advanced. And that brings me to the final API and my favorite API, which is the Video Intelligence API. It's one thing to understand text or speech or even static photos, but sight, sound, and motion in video is, to me, a completely different ballgame. And as a former film person, to me, it's very, very close to my heart. So a lot of the things that are in the Vision APIs are also in the Video Intelligence API. It can detect objects such as dogs or humans in the video. It can detect faces and actors. It can even detect when editors are making shot changes within the video on a very, very accurate level. But it can also identify events that are happening in that video with pretty good accuracy. So if you're watching a sporting event, you might see goals or a three-pointer. The Video Intelligence API has the ability to identify those events and really zone in on them to create which you can use to create personalized experiences for your users. So if I want to see every three-pointer by Steph Curry, it's possible to take all of the Warriors games and then edit that just to show those those three-pointers to me personally. And the applications of the Video Intelligence API for large media companies is actually quite transformative when you combine it with the rest of Google Cloud Platform's services. So for example, if you are a media company that has large amounts of historical video sitting in a basement on tape, you can take those tapes, digitize them, store them on Google Cloud Storage, run them through the various APIs that we have, and attach metadata to it so that your entire video library is now searchable. And if we go to the demo, we can provide a very, very quick overview of what that would look like. So this is the Video Intelligence API, and we can take a video that is, I believe, a Google commercial set in Rio, and you can see once we run it through the API, it can identify all sorts of elements within that video, such as skyscrapers, crowds, even kind of coasts. So if you're an editor and you're looking for specific clips within this large library of content, you can utilize the Video Intelligence API to very, very quickly grab those and go. So if we go back to William Goldman's quote of "nobody knows anything," it's not quite as true as it used to be. There's still the magical element of content creation and bringing that kind of inspiration to life. But now we have the tools to codify and provide a taxonomy for how is that content interacting in the real world once it's produced. And once you have that data set up, you can start to derive all sorts of interesting insights on how your audience is interacting, how is it monetizing, what do people like versus not like, which can then inform your further content creation initiatives. So it's never going to be a panacea, but more information is always helpful, and these APIs are a great way of attaching that data to your various content. So where are we going, and how can we improve ML to be even more useful? This is a very nascent area that Google is working in called AutoML, or learning to learn. So if you recall on the deep learning slide that I talked about, data scientists and researchers actually have to do a lot of thinking about how do they set up their models. There may be large amounts of layers in a model. You might have a huge model versus a small model, so there's a lot of kind of thought that needs to go into that model. What AutoML does is that it uses machine learning to figure out what is the best model to run based on the problem that I'm trying to solve. So we're in the very early stages here, but the progress has been quite encouraging. So on this slide, you can see that the yellow line is where we were before AutoML, and the blue line is where we are kind of today with AutoML. So there's an incredible amount of improvement, even with small model sizes in terms of accuracy, if you apply AutoML to your machine learning algorithms. And an important thing to remember is while we're building all of these technologies and APIs for you to utilize, we're not just a tech provider. We are here to partner with you on your journey to ML. And we have a variety of trainings, programs, and solutions where you can interact with Google engineers who will meet you where you are within your cloud journey. Whether you're a 2-person company or a 2,000-person company, we believe that we have the right fit for you that we can partner with. And so thank you for listening to this session about media and ML, and please stay tuned for more Cloud on Air.
And welcome back to everyone from the Industry Solutions track. Now, one of the interesting things about Google Cloud Platform is that it was largely built out of the same internal infrastructure that we created here at Google for our own products. Now, in order to be more effective and efficient for a company, we've custom designed a lot of the infrastructure that backs the products that we're talking about. Now, this means that when your app integrates with our cloud services, it ultimately runs on the same servers that power everything from YouTube to Google Search.
And here at Google, we are very proud of our data centers. This year, Google reached 100% renewable energy for both our data centers and our offices. Nice. So this has been a huge focus for Google, as it was one of the first corporations to create long-term, large-scale contracts to buy renewable energy directly. And today, we're actually the world's largest corporate buyer of renewable power, with commitments reaching 2.6 gigawatts of wind and solar energy.
That's a lot of gigawatts.
That's a lot of
Now, data centers are the backbone of the internet, processing and storing huge amounts of information. Our engineers have spent years perfecting Google's data centers, making them 50% more energy efficient than the industry average. But we still need a lot of energy to power the products and services that our users depend on. Now, that's why we began purchasing renewable energy, to reduce our carbon footprint and address climate change.
And when you build with Google Cloud Platform, you become a part of that. Your app runs on a completely green server in a completely green and intelligently designed data center as part of a green company. It's just a little something to feel good about.
Yeah, which is nice, right? It's not necessarily the first thing you're thinking about when you're building cloud services on our back-end infrastructure and our data centers. You kind of think of it as being out of your hand. So it's a nice little bonus to know that it really is. We think about that stuff for you.
Well, it's also a lot of small or medium-sized companies. They care a lot about things like this, but they don't have the flexibility or just the revenue to put their money where their passions lie. And knowing that they can use a service where they get those same benefits for free, it can help everyone really make sure that their company is a representation of their own value.
Absolutely. I mean, if you're in a situation where you're trying to be carbon neutral as a company, it's kind of hard to do that for yourself, right? It's like buying offsets, putting solar panels on your roof to run your office. Like, this isn't simple stuff that anyone can do. Yeah, exactly. So it's one of the benefits of being able to move to our cloud. Like, that's already taken care of. All of your processing infrastructure is already carbon neutral, thanks to the advantages.
We're going to make it easy. That's our whole goal. Make everything as easy for you, even the cherry on top Sunday stuff.
Exactly. Now we'd like to welcome back those of you who just learned about real-time insights. We just finished talking about how Google has reached 100% renewable energy for both its data centers and offices. Joanna, what is your favorite thing about our data centers?
Well, I've never been to one because they're really protected.
Yeah.
But I do think it's really cool how we use our own buildings to test our machine learning and AI algorithms.
Nice.
For example, our machine learning controlled AC systems notice that they can prevent server fires by cooling areas of the building in advance of large batch jobs instead of simply trying to cool active machines.
Wow.
And so that's really cool stuff that theoretically someone could have thought of, but having the computer program notice it that much faster made us more effective and better able to save money as a company.
Oh, fantastic. Yeah, I mean, it's really amazing some of the ways in which you can use these AI processes to improve things which aren't kind of obvious, right? And so being able to use that to analyze temperature trends within a large building and being able to figure out how can you modify the way that you're cooling things to, not just be more efficient, but actually to reduce the possibility of fires in the data center. It's kind of amazing. It's time to welcome back the AI track. Welcome. We've been discussing the clever and green data centers that Google uses to power all of the Google Cloud products that we've been talking about today.
Exactly. And one of the great things about a large company is that we have the actual physical space with interesting enough needs to play with. And these kinds of experiments are what really let developers hone the algorithms that we offer to others. So I think we should go ahead and introduce the next sessions. What do you think?
Outstanding, yes. We've got 3 more wonderful sessions along the same tracks that we have been looking at today. For the big data track, there's the Zen Guide to Data Preparation for Analytics, hosted by Eric Anderson.
For AI, Zach Stone and John Barris will take you through accelerated machine learning in the cloud. And in industry solutions, Jen Bennett is back, and she's discussing the new age of manufacturing.
Welcome back to Cloud on Air, the journey from big data to AI. I'm Jen Bennett, Technical Director in the Office of the CTO. As a reminder, we have Google experts on standby to answer your questions, so please submit them in the Q&A. We're going to talk about the perfect storm in manufacturing, reimagining manufacturing with Google Cloud. Now, not a day goes by that we don't hear a story or read an article about manufacturing. Manufacturing is so core to a number of economies globally. So whether it's Industry 4.0, China 2025, smart manufacturing, or the industrial Internet of Things, topics such as 3D printing, IoT, robotics, virtual reality, augmented reality, artificial intelligence. One thing is for sure. The pace of change and the disruption to business and society is upon us, as was noted here by Gary Coleman from Deloitte Consulting. And one thing, if you're like me, whenever you hear about new technologies, particularly manufacturing, you almost often hear about digital transformation, mostly in the same breath. Manufacturers have been turning to the consumer space, where the digital revolution over the past couple of decades has really brought about new technologies. And manufacturers want to learn about those new technologies, but also they want to look at innovation and what's enabled innovation in that space. So let's take a closer look. In the consumer space, what did we learn from connecting billions of devices and users? Well, for one thing, we learned that the scale of data became immense. Not only that, but complexity of data analysis, being able to deliver real-time insights. Also personalization with this overwhelming amount of information. And we've turned to automated intelligence for discovery. It's also led to a new paradigm of user experience. But one thing's for sure, that disruption and innovation came from connecting these devices in ecosystems, leveraging that data in new ways, maybe in some ways we never thought possible. The same is now happening in manufacturing. And as technology has evolved and matured, technologies such as cloud, big data, machine learning, these are becoming the digital backbone of Industry 4.0, or smart manufacturing. But it all starts with data. Data is the foundation of this digital experience. And what's interesting about that is that manufacturing is not new to data. In fact, manufacturing is a data-rich environment. Data comes from all aspects of the business: commercial, design, production, customer experience, but also from a number of external sources, perhaps from suppliers, logistics handlers, or even sources like weather. So breaking down the silos of these data and interconnecting them in new ways is really what's starting to bring new value, bringing new end-to-end insight, bringing all the aspects of business closer to the customer. This is what's going to enable new value streams. It's going to power the next wave of growth and really enable operational efficiency in ways in double digits that we haven't seen for many, many years. Leveraging this data and where the data comes from, the Internet of Things is really an enabler. So connecting machines, devices, material, products, this is a source of a lot of that data that we just talked about in the previous slide in that graph. Enabling this valuable information to participate in a broader ecosystem will create new, innovative, and disruptive opportunities that we frankly weren't able to see in our siloed world. So whether you're targeting new services for your customers, perhaps better engagement with your suppliers, or improved productivity internally, IoT is really a fundamental enabler. With Google Cloud, we've been developing IoT solutions for many, many years. In fact, we've leveraged this same technology that's leveraged in, or same innovation that's leveraged in products like Nest, to be able to bring better device management, better data collection, data processing, and even analytics. So as you embark on your IoT journey, and sometimes it's tempting to just create a new silo of data, but really focus on a truly connected and innovative ecosystem where IoT applications really bridge and federate data to solve problems in new and innovative ways. This is really where Google has excelled, having a history of excellence and commitment to open and innovative ecosystems, such as the Android ecosystem. Now let's take a look at big data and machine learning. In manufacturing, we've really struggled with the amount and the variety of data and the ability to gain useful insight from that data. So some of our traditional systems really struggled to scale globally. Perhaps they weren't cost-effective when they grew at scale. And in fact, many of them struggled to handle the variety and complexity of data. When we would run reports, sometimes they'd take days or perhaps even longer. So we really restricted the access of data and really drove individual productivity or individual group productivity with the data that was required. What we're talking about here with big data is really unleashing the power of the data to the organization. We've started to see a real shift in manufacturing around descriptive analytics, this idea of being able to tell and show visually what's going on now. And this is really important. It's a fundamental starting point. This has allowed us to start to see common problems. And in many ways, the 80% problems are very interesting and useful to tackle. But one of the things that we learned from the consumer space is that the long tail problems are really difficult and very time-consuming if you rely on the traditional methods of solving these. This is really where we start to see machine learning shine. We're going to talk a little bit about that in more detail. But let's first start with big data. Google's had a long, storied history around big data technology for over 15 years. We've started by writing white papers, which have often led to very popular open source projects. Technologies such as BigQuery, which has been refined over 10 years, powers some of the world's largest applications. BigQuery's ability to scale and be performant for interactive analysis is really unrivaled. This has enabled virtually all functions of the business to have access to data and for organizations to truly become more data-driven, really unleashing that power of the data like we've never imagined. Think for a minute. I can query 1 million rows of data in under seconds. Then I have an idea that that data gave me some insight. I can do another query, a few more seconds. It's really phenomenal. We have technology such as Bigtable, which powers search and ads and Gmail and Maps. And with Google Cloud, all of this underlying technology is becoming available as managed services. Managed services like BigQuery, like Bigtable. Quite powerful for you to focus on what differentiates your business and not have to focus on the underlying technology. Unleash that power of the data to everybody in your organization. Now, big data is interesting, but what's really interesting is how it becomes the fuel for machine learning. So let me just talk a little bit about machine learning. The hypothesis here is that machines can be taught to learn, leveraging large data sets. And what does that really mean? Here we have computers that aren't pre-programmed with if-then-else clauses or complex decision trees. Instead, we're using mathematical functions to really simulate sort of the behavior of neurons in our brain. So we provide training data. Perhaps we provide a classification or a reward function, if you will. And we let the computer run numerous iterations to fine-tune the weights of those mathematical functions, all while success is being reinforced. So what you can see here is a game of breakout and work from our colleagues in the DeepMind team. No rules were programmed on how to play this game. Just data, pixels in and the joystick as output, and neurons, mathematical neurons in between. The reward function, of course, is score here. And as you can see, the machine starts learning, frankly, by random luck. It tries something based upon the data, receives a score, and then it adjusts. After 2 hours, the machine plays flawlessly. Double-digit scores. This is something for any of you who've played this game in the past. It takes hours to become, if not days or weeks, to become an expert player. And this is really 2 hours for a machine to learn how to become an expert. But an amazing thing happens next. After just 4 hours, not only has the machine become an expert, it's actually learned how to optimize score through developing a strategy. Yeah, I said it, strategy. This machine has learned strategy, and it's learned the strategy in breakout of breaking out a side of either side so that it can get up on top and knock out a lot of blocks and really take a score from being single or double digit into triple digit numbers. This is really the power of machine learning. We often see these double-digit improvements where, as humans, we really struggled to get single-digit improvements. And this same technology is the technology that beat the game of AlphaGo, which, as many of you probably have heard, has a larger search space than the number of atoms in the universe. So why is big data important? Well, big data, as I mentioned, is really the fuel for this machine learning. Machine learning improves through experience, through data, similar to humans, but to get better, we require data, and of course not just data, but also large-scale compute and efficient compute, so that we can iterate. The machines can iterate over and over and try new weights on a very rapid scale. We'll come back to that idea of large-scale compute in a little bit. Now, we saw machine learning playing games, but it's not just for games. And so kind of coming back to manufacturing, I have an example here of operations. For 10 years, we've been building and running some of the world's most efficient data centers. And we place a huge focus on reducing the cooling overhead of these data centers. After 10 years of work, we got it down to about 12% annual overhead across our fleet. That really was amazing. And over the years, we've collected tons and tons of data from the data centers. So one of our data center engineers, along with the help from the DeepMind team, decided to try out machine learning. To our surprise, the cooling energy was reduced 40% during the summer. 40% over a heavily hand-optimized solution. The experts. Difficult to believe. So we turned it off, and sure enough, back to where it started. So this machine learning algorithm optimized significantly better than the experts. And frankly, it took less than a year to go from experiment to production. Of course, machine learning is still nascent, and so but it's sure to have a dramatic impact to the manufacturing world. So now let's think about it. We leverage data from IoT, we analyze with big data, we optimize with machine learning. We can build new digital applications powered on all types of devices, even including devices such as Google Glass, where we can now build augmented experiences within our enterprise. So imagine every one of your factory floor workers having a personal assistant to provide information. These new applications can also scale globally as your business grows, really all by the power of Google Cloud. So that brings me to cloud. Really, all of this is made possible by the cloud. It provides the scale, the security, and the compute necessary. And remember, with Google Cloud, this is all the same technology and infrastructure that powers Google's products. But in manufacturing, it's also important to remember edge. Edge to cloud is really critical. And it's really incumbent upon us to mention that we're firm believers in the edge, and as you probably know, Android powers a number of edge devices. But we enable an edge-to-cloud experience from device management, data collection, filtering, real-time analytics, even machine learning at the edge, and managing the life cycle of that. We also believe in the hybrid cloud. So as you embark on your journey, pay attention to containers and how this can enable portability for your applications, but also future-proof your business as you move to the cloud. So let's bring all those technologies together and really start to look at the 4 key pillars in manufacturing. You can see that Google Cloud has capabilities to enable transformation across your enterprise. So connecting data throughout the life cycle of a product or a process, providing a digital thread. Or perhaps if you're looking at a digital replica or a digital twin of a process or a product, enabling you to build a model that allows you to run simulations or what-if analysis. The data center example I mentioned earlier is a great example of this. We can leverage that model now to do simulations or what-if analysis of things if they change. That's a digital twin. Perhaps you're looking at new business opportunities, growing your top line, or providing better customer experience. This is all powered as well by Google technology. Or last but not least, probably just as important, your workforce efficiency. How are you transforming your workforce to become more digital? How are you enabling them to have that personal assistant, to be able to get data when they need it? Creating an immersive and collaborative and intelligent experience for your workforce. And don't forget training, really critical as we look at these new technologies and this disruption. We've got to enable a workforce with training and collaboration. I'm going to walk through a few examples of each of these. Let's start first with a supply chain example. So here we have a customer, California Design Den, who's been working very closely with our partner, Pluto 7. Now let me tell you a little bit about California Design Den. They're a textile manufacturer that supplies both private label as well as national brands. They were moving from a traditional retail to an online retail. They wanted to effectively forecast customer demand, whether it's for seasonal trends, whether it's for large spikes in sales. But they also wanted to manage the highly optimized distribution supply chains with optimized inventory and high service levels. Now, their challenges were their existing process really couldn't handle the dynamic nature of demand changing. Their factory operations had to deal with a large number of fabric costs due to wastage, and as a result, their inability to react to demand change. The warehouses had to keep a high amount of safety stock, and that can lead to higher costs, also the probability of obsolescence. So working with our partner, they were able to integrate customer demand, manufacturing, warehouse, and inventory, and able to anticipate and predict demand changes. And what did this enable? It enabled them to increase productivity, but it also enabled them to reduce inventory by about 30%. That's pretty significant business impact, double digit. Let's look at another example. This is an example from our partner Maven Wave. So here we've looked at how can our partners working with a number of manufacturing customers leveraging Google Cloud to weave a number of technologies like machine learning for prescriptive maintenance of the shop floor machines, or machine learning for image recognition, for quality control. But also, you'll notice on here, they also delivered new experiences, collaborative experiences between R&D and manufacturing, leveraging technology such as Jamboard. So this is how we can leverage Google Cloud in a manufacturing environment to start to deliver the digital experience of the future. I want to go through another example here. This one comes from Kewpie, who manufactures baby food. In this case, when we talk about quality, it's not necessarily a matter of life and death because the food itself is safe. But what happens is these potato cubes can become discolored, and that can cause concern for parents. So Kewpie turned to Google and one of our partners, BrainPad, to build a solution which leverages our expertise in image recognition on Google Cloud to detect the low-quality potato cubes. This machine learning algorithm enabled them to free up people from some tiring and very tedious work, often very error-prone, to focus on other important work. We're really starting to see a number of use cases in this space of visual inspection or image recognition, leveraging the models that we've built and refined over many, many years, the technology that has evolved to enable new experiences on the shop floor. Another example. This comes from our partner ClearObject. They've been working with a very large automotive supplier. And this one really talks about new business models. So they've been able to leverage our technology such as PubSub, Dataflow, BigQuery, and App Engine. These are technologies that I've mentioned before, to stream data from the field and get real-time visibility, delivering a better understanding of not only how products are used, but to ultimately build better products. So when we talk about this idea of predictive performance and how that can build a model, that real-time data can build a model, so that then they can enable better experiences for their customers. Another example of really transformational use cases leveraging technology from Google Cloud in manufacturing. So as I've pointed out, Google Cloud is really an end-to-end platform built on the same technology that powers many, many of Google's businesses, the same infrastructure. And this is from storage and infrastructure through to data and analytics, machine learning, all the way to devices and team productivity. And we've built one of the world's leading enterprises on the same technology, and now you can transform your business as well. But it's also designed in a way that allows you to adopt as little or as much as you deem fit to solve your business problems. But what's also important is that we believe that an ecosystem is really critical to driving innovation. And so we've enabled and have a great network of partners that not only have chosen to work with Google, but have also chosen to work with each other to create better products and applications for our customers. This is the type of ecosystem that's going to emerge and allowing disruption and new innovations to be developed. So really, as we think about it now, there's a lot of business challenges that we face in manufacturing. Whether it's in the cycle of rate of change of product design, whether it's in highly optimized productivity gains, reducing inventory, whether it's increasing the availability of machines so that our productivity time isn't impacted by downtime, whether it's by better enabling our supply chain. There's a number of different opportunities inside of manufacturing. But we truly are at an inflection point. We're about to experience unprecedented change. These technologies that have matured and have been developed in the consumer space are really enabling and evolving quite rapidly. And the disruption in manufacturing is really just around the corner. So I ask you, where and how will you get started? And who are the partners that you're going to enable in your ecosystem? Start thinking about your data strategy. Data is really important. Start thinking about how you're going to commercialize that data. Make that data accessible not only to your own team internally, but also to that ecosystem of partners to enable new applications to evolve, new applications to tackle these business problems, new applications to be able to drive better customer experience, to be able to understand your customers better, to be able to understand how your products are used, to be able to build those digital twins. I'm going to leave you with a quote. as was stated here by McKinsey and Company, one thing really seems certain. Digital will lead some companies to great success, while slow-moving competitors will fall behind. We want to be part of that change. We want to be part of the success. And in manufacturing, we have so many challenges. The technology is available. Leverage the technology. Learn. Start by doing some POCs. Start by learning. Create an environment where your employees are engaged to deliver new insights to how we could do business better, to how you can engage better. This is really where it starts. This is becoming a data-driven organization that empowers the employees to be innovative, that empowers your ecosystem and your partners to be innovative. With that, I say thank you. Again, just as a reminder, we have Google experts to be able to answer your questions, so please submit them in the Q&A. Thanks so much for watching, and please stay tuned for the following sessions.
Talk about the dream 15 years from now.
Absolutely. Now, we're going to take this opportunity to welcome back people from the session New Age of Manufacturing. Now, Joanna, question for you. As a continuation of what we were just talking about, we have a question here about how an AI can become more intelligent than just an if-then-else statement, or a large grouped collection of if-then-else statements.
So this is a good question, and it's still interesting because it hits that same point.
Absolutely.
Technically, computer programs are quite simplistic, and as programmers, as we talked about, we're the ones who make them more interesting. So if you studied computer science at a school or university, you probably had to do some work with basic circuits in order to appreciate the beauty of programming.
Yes, understand
how
it works at the low level. Yes.
And if you remember, the main point of those classes is that technically, all a circuit can do is add.
Exactly.
That is the only thing that these beautiful motherboards we build can technically do. They can only add one at a time, this bit and that bit. And that's it. And if you string together enough of those adders and you apply some arbitrary meaning to what that does, you can actually create the complex machines that we have today, as well as the complex programming languages we use to build on those machines. And if you carry that metaphor through, the if-then-else argument, you actually have two different avenues to go here. This boring one, where a truly complex nest of millions of if-then-else comparisons, the same way we have millions of adders that are all processed insanely quickly. But there's also this world where we're constantly assigning that arbitrary data, that value, the metadata, to an object. And if, say, a sentiment analysis program is able to tag a phrase with not just positive or negative, but slang usage, reclamation data, etymology notes, you can build a word map of that phrase that can offer the computer much more information to work with when it goes through that if-then-else flow.
That is a long and complex answer, but absolutely true. So basically you're saying, no, it isn't more than just if-then-else.
No, I'm saying no. But, I mean, not technically. So no, I'm saying no. But in actuality, we can create so many interesting and complex spaces for our AI to learn. And that's what we were talking about, too, as the IS team joined in. But it's like, we have, again, we have the today, the tomorrow, the next 5 years problem. We also have the 50 years from now. What are these going to be doing? In order to reach that point, we have to start with the difficult and tedious things today. And then we translate that into assembly language, and we translate assembly language into like hex language, and we translate hex language into like, COBOL and Fortran and punch cards. And then one day we get Python, and it's so nice.
Yeah, absolutely. And I think that's often what we're sort of dealing with, particularly around AI at the moment, where what we're building is tools that make it easier for people who aren't maths PhDs or don't understand how to write assembly language, to be able to find ways to devise solutions to those problems without having to manually build adders themselves, right? You don't have to build our own circuits, we don't have to build our own transistors. We can start using more and more complex, and we're able to use programming languages which are able to represent a lot more symbolically without having to understand exactly how all of the plumbing works underneath.
And it also means that if you can't find your exact help that you need, it might be that you have a use case that no one else has thought of yet, and so we might need to tweak our tooling systems, and that becomes just part of being in the community and being able to have these conversations and share ideas. We just so much inspiration and knowledge to grow from. We're so early in the stage, even though we've been talking about it for probably a decade.
Yeah, I mean, I think that's one of the most exciting things, is that we really are so early on, particularly in AI, and a lot of the cloud stuff, which we take for granted because it's like, well, we work at Google and cloud is kind of where everything happens. But for a lot of the industry, this is by itself, big data, working in the cloud, all of this is actually really new. And with AI in particular, it is really groundbreaking. So there's this great opportunity for people to, become part of the community, figure out what the underlying problems are together before it becomes a question of how do they solve those problems.
So now we're welcoming back the AI track, and hopefully what you just missed is how exciting it is to be in this field. And so now we're just going to tell you about our final 2 sessions for the day.
For the final sessions, we have 2 great options to go away and check out. The big data track will conclude with Scott Ellis's Putting Data Security and Privacy into Practice with Google Cloud. We talked a lot about security earlier, so this is a really interesting session. You'll want to check it out. We mentioned this talk earlier today, as I say. This is a great way to wrap the event for everyone interested in building great apps with confidence that their data is safe.
Exactly. And then we're combining both the AI and industry solutions tracks for the extended version of Quentin Hardy's Fireside Chat with Suzanne Johnson, Employment Branding Manager for General Motors, and Jessica Lee, Vice President of Global Talent Acquisition Strategies and Solutions at Merit International, to discuss how they are using artificial intelligence to tackle common business problems. Y'all have fun.
Google's AI building blocks are ready-made frameworks that enable non-specialist developers to rapidly engage machine learning to tackle a broad range of common business challenges. As we'll see, common does not mean ordinary. You put AI on some of these problems and you create an entirely new level of value. Let's look at the Cloud Job Discovery block. It's a way to transform the tough problem of finding and hiring the best possible people. Google applied AI to millions of job postings, creating a new understanding of what employers want in a new hire and what potential employees are looking for. Let's talk with Marriott International and General Motors, 2 of our newest customers for job discovery in 2 very different industries. I'd like to welcome Jessica Lee, Vice President of Talent Acquisition Strategies and Solutions at Marriott, and Suzanne Johnson, Head of Employment Branding at General Motors. Talk about your company in the context of its people needs. What are some of your biggest challenges vis-a-vis hiring?
We are the world's largest hotel company, which means that we have over 6,000 hotels in 110 different countries, and that's a lot of people that we need to hire for all of those hotels. So in any given year, we hire more than 100,000 people per year, so that's a lot of hiring that we're doing, and that means at any given time, we've got over 15,000 jobs open, and so in order to fill those jobs, we've got probably 3 to 4 million different applications that are coming in per year, and millions more who are just simply searching or perusing our career site. So it's a lot of people. And
that's in how many languages? How many countries?
Over 20 different languages in 110 countries.
So when we talk about posting a job availability, we're talking about an immense data problem as well, because you said 12,000 at any given moment openings. That might be described in any number of ways, but there's a Marriott way to describe them that the applicant may not know about.
Sure. So I think every company probably deals with this when it comes to a very company-centric way of describing positions or an industry-specific way of describing their roles, yet we're open to people coming from all sorts of organizations and industries to come work for us. And the example we always like to give is that we have thousands of servers that we employ, and you'll find hundreds, if not thousands, of server openings on our career site right now now who are going to be working in our restaurants.
Well, at Google, we have millions of servers, but it's not the same.
Yeah, I mean, those servers can't feed people